Good morning. I hope you guys are all here for a session on hybrid connectivity and workload mobility, as opposed to simply having come back because the chairs are very comfortable and we don't often get a chance to sit in a planetarium. So this is really a fantastic venue, right? And Joe delivered a fantastic keynote. Again, I hope you're here not because of the chairs, but because of the new content. We agreed that Joe was going to be my warm-up act, and so hopefully he did a great job on that. And so now what I'll do is talk about VMware Cloud and AWS. So good morning, everybody. I'm Vern Bolinius. I'm part of the VMware Cloud on AWS specialist team. And what I'll cover in the next 45 minutes is how you can connect your on-premise environment to VMware Cloud on AWS and show you, with some demos, how you can move your workloads back and forth. Because cloud is great, but until you start putting stuff in it and start using it, it's just a bunch of resources sitting there not doing much for you. So I'd say we can do questions, but A, I can't see you, or not very well. And B, just from a timing perspective, we might be running a little bit tight. So what I'd suggest, if you don't mind, let's hold off questions until the end. And if we do run out of time, if it gets tight and you have a burning question, I'll hang around. You're more than welcome to come up and ask. So here's what we'll cover. We will take a look at, okay, or not. Right, manual it is. Or not. Hold, please. Really? Okay, it's not just the clicker, it's the fact that the PowerPoint itself isn't doing anything for me. Great, I can get demos up. Let's start exiting and restarting. Or not. No, space. Good plan, but no. Okay, it's the definition of insanity, right? Doing the same thing over and over again, expecting different results. Okay. Yep. Yep. This one here? Okay. Okay. But if I go back and forth here, I still get that. That's all right, we'll do this. And I'll hide this. Okay. Let's make this a little bigger. Oh, sorry, make it a try. This is what the problem was last time. Let's see. Okay, different mode, good. Right, we'll start that again. This is when you hate when the whole thing is recorded, right? Like, no one saw that. This is not the show you're looking for. So here's what we'll cover. Well, first of all, let me ask, how many of you have some familiarity with VMware Cloud on AWS? Okay, a few, which is too bad now I can't make stuff up. But what I'll do is I'll do a very brief overview of the solution to put it in context with the rest of the things we're talking about as far as the connectivity and the mobility are concerned. And then I'll talk about the hybrid connectivity and the workload mobility. So, like I say, a very, very brief overview. So starting up, Joe, all of you were here for the keynote, yeah? Nodding heads? Okay, so you've seen this slide. It's been VMware's slide for a number of years as far as our vision. Really, any application running on any device in any cloud. And for here now, what we'll focus on is the lower part of the stack. We'll take a look and keep with the hybrid cloud piece here. I normally can point, but it's a little difficult on a screen that size, no matter how short I am. So we'll focus on the hybrid cloud piece. So a little bit of history. In 2016, VMware and Amazon got together and announced that we would jointly build a solution that would allow VMware customers to run their workloads, their vSphere workloads, on bare metal Amazon. This is a big deal because customers are increasingly interested in cloud, and there are roughly 100 million vSphere workloads out there in the wild, and so the ability to take those workloads and move them onto bare metal Amazon and keep them as vSphere workloads without having to change them, very appealing. So it was built to address 5 challenges that some of you have very likely encountered if you've already started that journey down to cloud. So the first, Joe talked about the operational consistency and infrastructure consistency. This is doing things the same way on-prem as on the cloud, as opposed to having 2 completely different methods of managing or monitoring that infrastructure. The second, using existing skill sets and tool sets. Customers have invested a lot of time, energy, money, not just in the VMware infrastructure, but also in the people that manage it and the tools that they're using to do that management. Wouldn't it be great if you could just move things straight across and use both the same people and the same tools? The next 2, the security and the SLA, they speak for themselves. You have to have equal or better as you move to cloud, but it's the last one that's the kicker. When you move to cloud, to native cloud, whether it's Amazon or Azure or Google, turns out it's not easy. Having to re-architect or change that application significantly in order for it to fit in the native cloud world is difficult. This solution allows you to just lift and shift stuff across from your on-premise environment into the cloud. Okay, so with that, let me go over the meat of the solution. So what you're seeing in the center is the core. It's hyperconverged infrastructure, combination of vSphere, vSAN, and NSX. That's a physical box. It's a physical server or set of servers, a cluster, that sit on bare metal Amazon. It's not a layer 2 hypervisor solution where we're taking an EC2 instance and we're putting ESXi or vSphere on top of it. It's sitting physically in Amazon space. We're taking that and connecting it through the connector on the left here, through that connector. So that connector is going from on-prem into VMware Cloud on AWS, and that's what I'll talk about for the majority of our discussion here. But the third part of the solution is the connectivity to native Amazon. So this allows the workloads that are sitting in the middle, your vSphere workloads, to directly leverage some of the Amazon native services, EC2, S3, RDS, elastic load balancers, and the link that is between them allows for 0 ingress or egress charges. So that's part of the solution. A good example of that might be using a popular software package, I'll pick Veeam since a lot of folks use Veeam, to back up your VMware vSphere appliances or virtual machines from the middle section, VMware Cloud or AWS, into an S3 bucket, as an example. Okay, so that's the crux of the solution. Oh, sorry, one other thing I should mention on the right here. You've seen that I say service highlights. It's a service, which means that any of the patching, the upgrades, the maintenance of the physical hardware, that's no longer your responsibility. It's VMware or Amazon's responsibility to take care of that. Okay, it's a very appealing part of moving to managed infrastructure. So what it really means is now we are taking cloud, or we have the ability to take infrastructure and deploy it as fast as we can deploy virtual machines. How many of you are familiar with that concept? In 86 days, I've spoken to customers where, I spoke to one customer recently where they've actually said, Vern, it has taken at one point a year to fully provision a server, and by that point the hardware is obsolete. So now we've taken it from 86 days down into about 10 minutes. So it takes about 2 hours to build the full software-defined data center of 3 or 4 hosts at a minimum, and then only 10 minutes to add another server after that, which can be done programmatically or automatically or manually. So we're deploying infrastructure as quickly as we're deploying virtual machines. So the use cases for VMware Cloud and AWS, there are 4 primary use cases. The first one, data center extension, the case where you have your on-premise data center and you're stretching across to a cloud data center. Perhaps you're doing development in it or you've run out of space. You are going to move some workloads across, but you're still keeping your on-prem. The second one is disaster recovery. How many of you are familiar with or are using Site Recovery Manager? So a good number. So SRM, Site Recovery Manager, has been a flagship VMware backup product for the better part of 10 years. And it relies on vSphere replication, or replication of virtual machines from on-prem to a secondary site, a secondary recovery site. Now, as opposed to having to maintain that secondary site, it can just be VMware Cloud and AWS because it's just VMware, just vSphere under the covers, so it makes an ideal target. So that's the DR use case. The one that I encounter the most is cloud migration, where customers are exiting a data center. Maybe it's a colo, maybe they're exiting for budgetary reasons, their contract is ending, and they need to get their VMs, their workloads out of that and into cloud relatively quickly. They don't have, a hope in hell of having to go and re-architect all of their 200, 300, 2,000 applications. They need to move that across. So again, that's one of the places where VMware Cloud and AWS shines. The last use case is next generation apps. We heard Joe talk about the construction of next generation apps and what vSphere, what VMware is bringing to the table in that. And so running those in VMware Cloud on AWS is the fourth use case. So now that we've talked about the use cases and standing it up, let's talk about the connectivity. Again, great, we've gone and we've stood up an environment, a cloud that's ready to receive workloads. Now what? How do you connect that to your on-prem? And by the way, some people don't do that. We have customers, very few, that have just built this island of cloud compute that they can use as a completely separate, isolated piece of infrastructure for testing, for development, for whatever the case is, without connecting to on-prem. That's totally fine. But in most cases, we're going to talk about, or most cases, customers are looking for ways to connect the on-prem into cloud. So let's cover that. Okay, so here's what we have. On the left, you have your on-premise environment. You have your management workloads, your vCenter, whatever other management pieces you have. You have your workload or your compute down at the bottom. And then on the other side, we have the software-defined data center, the VMware Cloud on AWS. So gateways on both sides. So we have our on-prem gateway, our internet gateway on the AWS side, and in here sits the software-defined data center powered by NSX. So you have the management gateway. Is this easier? Yeah, it might be easier. So here we have the management gateway, behind which are things like the virtual center server, SRM, if you're using it, the NSX cluster controllers, the NSX manager. And down below, we have the compute gateway, which is where the customer will keep their workloads. So that's completely under your control. The top is managed by VMware, largely. So that's the way to look at that. So the first thing that I want to do to connect the two environments is to establish a VPN. This is a very straightforward layer 3 VPN, no magic to it. The VPN IPsec is a well-known construct, so I'm putting that in place first. And through that, I'm going to run my management traffic up to my management gateway, and I'm going to run my compute traffic down to my compute gateway. So the top allows the two vCenters, as an example, to talk to each other, allowing for one pane of glass view of both sides. The bottom are VMs talking to VMs, leveraging services that are still on-prem, like Active Directory or DNS. So we've meshed that out. That top piece, the management piece, hybrid link mode, that's that same pane of glass. Or perhaps I'm doing cold Vmotion, or cold migration, not cold Vmotion, just turning off a virtual machine, migrating across, and I'll show that to you. The bottom part is VM to VM traffic. But what if I want to stretch a network from my on-premise environment into my cloud environment so that I have layer 2 adjacency on both sides of the fence? For that, I can install an NSX standalone edge, which is free, on my on-prem environment, and I can use that to form a layer 2 VPN between on-prem and the cloud. And what that means, and we'll have a little green line there at the bottom, so I have now the 192.168.10.0 network on both sides. So the VMs are layer 2 adjacent, have layer 2 adjacency. So that's great. There are multiple options of configuring. That's what I'm covering in this, and hopefully that's what you'll take away from this. So if I didn't want to do that, if I didn't want to have that layer 2 stretch, there's a better way of doing it. I still need my IPsec VPN tunnel in place, but there's also a tool called Vmware Hcx, which some of you might be familiar with. It comes with the VMware Cloud and AWS solution. It's an add-on that's already there for you. And it will do the layer 2 stretch and more. So it is the tool of choice. It'll do cold migration, warm migration, bulk migration. You can schedule the migration from on-prem into the cloud and back. So it is, again, it's built in. It has sweet B encryption. It has WAN deduplication and compression. Try saying that 5 times fast. And so it is the tool of choice by far for moving workloads back and forth, and I'll cover that when we talk about how you can migrate. But A number of customers also have AWS Direct Connect in place. How many are familiar with Direct Connect? Okay, a number of you. So effectively, it is Amazon's high-speed, low-latency link to connect on-prem into cloud, okay, into one of their VPCs. And really, this on the left, on the right here, my left, your right, is the VMware Cloud on VMware Cloud in AWS is just a special kind of VPC. So it's an Amazon construct in which the VMware environment lives. So you can use a Direct Connect to move workload directly, or move workload and all network traffic from on-prem to the cloud. And if you have HCX or if you have a layer 3 VPN, those can be piped through Direct Connect with a virtual private interface, a private VIF on AWS Direct Connect. You wouldn't even need the VPN unless you wanted some greater security. So those are some methods of moving the workload, or different ways of moving that workload across. I like this slide because it shows the options and provides a little bit of clarity, because there are a number of options. So going over it, the first, layer 3 VPN, connecting one subnet to a different subnet, can go over either straight internet or it can go over Direct Connect. Second option, if I'm going to stretch network, a layer 2 VPN, it can go again over straight internet or be piped through a Direct Connect. And that gives layer 2 adjacency on both sides. The third option, HCX, which again, usually supplants or supersedes the need for, or obviates the need for a layer 2 VPN. It can also go over Direct Connect or go over bare internet. So those are the connectivity options from on-prem into cloud. So think about those. I'll do a quick summary at the end. And if there are any questions on that, or how some of those work in a little bit more detail, you can ask if we have a time slot, or come and see me afterwards. So now that we have our two environments connected, how do I move workloads? Well, what we're looking for is something like this. We really want that ability to smoothly move workloads back and forth. That's a big win in the solution. And some have asked me in the past, Vern, do you really have customers that move stuff back as opposed to moving everything over to the cloud? And the answer is yes. There are cases where maybe you're doing development in the cloud. Once it's ready, you're moving it back. Another example is in the UK, the Financial Conduct Authority demands or mandates that any financial institution that is going to explore cloud needs to show evidence of being able to get out of that cloud, whatever that cloud is, in case the cloud goes belly up, in case they don't pay their taxes, in case they get hacked, whatever the scenario is. In this case, I literally can take those workloads and just slide them back over to on-prem. So here's what we'll talk about. I'll talk a little bit of detail on hybrid cloud extension, or HCX. Live migration without HCX, because we do have customers that do that. Cold migration, very straightforward, just moving a workload across without having to have anything special in place. Content library, for those of you that are using or familiar with content libraries, great way to keep in sync templates, ISOs, scripts across two different environments, two VMware environments, and a little bit then on enhanced Vmotion compatibility. So the first thing to do is to decide for yourselves what your needs are as far as downtime is concerned. Do you really need to live motion or to Vmotion all of your workloads? Maybe you do. But in most cases, there are options you don't need live migration for everything. So decide, which buckets should these go in? Do I want no downtime, low downtime, or is full downtime completely acceptable, where I'm turning that virtual machine off? So let's bucketize these, and then from there, decide upon the right solution. So a little flow chart. So this is without HCX in place. So migration, let's go with downtime first. I can take the downtime, I can turn my machine off, and I can move it across. What are my options? Or what do I have to do? So on-premise, you're going to use a standard switch or a distributed switch of version 6, 6.5, or 6.5 plus, 6.5, or 6.7. On the cloud side, remember you're always going to need that IPsec VPN. You're going to configure firewall ports to allow that traffic through. Move over to live motion. So now, no downtime. Again, HCX isn't part of this yet. So I'm going to Vmotion. So there are some prerequisites for Vmotion. Again, on-prem, I need a distributed switch. I also need VM compatibility version 9 which equates, for those of you that can take it back a bit, which equates to vSphere 5.1. And then on the cloud, I need IPsec VPN, again, always. I have to poke holes in my firewall. I will need a layer 2 VPN with the standalone edge that I mentioned earlier. And remember this, in order for Vmotion to be supported without HCX, you will need a Direct Connect. So the bandwidth required for Vmotion to guarantee that it's going to be successful requires Direct Connect or it won't be supported. So bear that in mind if you're doing a Vmotion layer 2 stretch construct. Okay, now layer in HCX. So HCX allows this. It allows that bulk migration. I mentioned earlier it has the WAN deduplication and compression, as opposed to requiring, and I'll go into some of the stats, as opposed to requiring 250 milliseconds RTT. I can do this with 100. I can also do this with 100 megabits, as opposed to requiring a direct connect. It supports the distributed switch. You note here I call out internet or direct connect support for bulk migration. This is a big one. I have the option to say, migrate 100 virtual machines over from on-prem into the cloud. And the way that I'm doing that is by scheduling and, well, what I'm doing is establishing a vSphere replication. So HCX puts vSphere replication in play under the covers, and I'm seeding the virtual machines in the cloud over a period of time that I specify, that I schedule. At the end of that period, I can either do a warm migration where I turn them off on premise and I turn them on in the cloud, or I can finish that off with a Vmotion. So over the course of, again, a week, let's say, things get migrated over to the cloud. They stay in sync with what's on-prem. At a scheduled time, I say, okay, now that I have all my bits or most of my bits in the cloud, let's do a Vmotion across. So that's what HCX will do for you. So it is already built in. It's there. This is a screen grab of the add-ons section within the VMware Cloud and AWS console or in the UI. You'll see that it's already active. So if you look in as soon as you establish your cloud, it's active. You simply say, yeah, I want to use it. On the cloud side, a set of appliances get stood up. You get an OVA to install on-premise, which then once you start configuring that, breaks up into the same 3 appliances that are on the cloud. The 2 appliances, the 2 sets of appliances connect, they peer together, and then you can move stuff back and forth. So, some support along HCX. You can see that from 6.7 right down to 5, you can do all bulk migration, cold migration of Vmotion with the exception of vSphere 5 and 5.1. And this reminds me of something else that's important with HCX. You can take an older version of vSphere, let's say 5.5, and I can live motion that directly to cloud, which is on 6.8, without having to change that virtual machine at all. So this can be part of an upgrade path as well. So I think from a timing perspective, I've got a moment just to demonstrate a live migration with HCX. So what I've done, this is going to work. Okay. So what I've done, I have a virtual machine set up which goes into the lab environment, and I'm going to log on to the VM. I'm going to log on to the VM. There we go. And what I've set up, or what I'm focused on, is all right, I won't say anything until it actually comes up because maybe I'm not focused on it at all. There we go. So I am looking at a vCenter that is on an on-premise environment, and that on-premise environment, as you'll see in a moment, where's my mouse? There we go. So my on-premise environment happens to be in Austin, Texas, and my cloud environment is in North Virginia. So this is US-based. And once HCX has been installed, it becomes a plugin. So if I click on my plugins here, you'll see that HCX is one of the options here. Sorry, the response time is a little slow. Okay, so the first thing I see is a dashboard, and again, this will show me where my cloud is down here in Austin, Texas, where this is my on-prem, sorry, that's my cloud. It's about 2,000 kilometers apart. And what we're going to do is migrate a virtual machine live between those 2 locations. So I'm going to jump directly into migration. There's more to show on this, but we just don't have time in this session. And from here, I can click on Migrate Virtual Machines, and I can pick a machine. It's going to show me my inventory on my on-premise environment. And so I'm going to go down, and I will pick a Migrate machine. I have some set up here. Migrate, where did my machine go? Now it's hiding on me. There we go. Migrate 05 or 03, one of those is going to be fine. Let's do Migrate 02. So I'm going to pick a machine to migrate. It's going to ask me where I'd like to put it in the cloud, so I'm going to specify a folder. I have a test folder for that purpose. So I'm going to go and I'm going to put it in test. Likewise, it asks me for my resource pool. I have a test resource pool that I'm going to dump it in. I shouldn't say dump it in, it sounds bad. And finally, I'm going to select my storage, which is my workload data store on my cloud side. Here's where I have the option of doing a bulk migration, but in this case, I'm simply going to do a single live Vmotion. Click on Vmotion. If I click Next, it will check. Everything is good to go. I click Finish. And that virtual machine, it says waiting. It'll take about 2 or 3 minutes, depending on the network traffic on that link, to go between the on-premise data center and the cloud. I'm going to let that run. We'll come back to it. So I can show you that it's moved across, but you can see that it's very straightforward. Hcx really does make it very easy. Hcx also allows you to directly and very straightforwardly through the GUI stretch a network from on-prem into the cloud. So while that's going, let's talk about some other stuff as far as moving across. So live migration, this time without Hcx in place. So this is where I'm doing a Vmotion, and so here are some of the caveats on the right here. First of all, here's my layer 2 VPN that goes from my compute gateway in the cloud to my on-prem, and I also have that layer 3 VPN already set up. So in this case, I do need remember before I only needed 100 megabits of bandwidth with Hcx, now I need 250. I do need a direct connect in place. I can use a distributed switch, or I can use a standard switch. Here's something to bear in mind with a standard switch. If I have a standard switch, I can migrate from on-prem into the cloud, which uses a distributed switch, but I can't migrate back. So if you're using standard switches on-prem, be aware of that. If you're using a distributed switch on-prem, no problem moving back and forth. I do talk about VMware compatibility, again, version 5.1 or above, and the EVC considerations I'll talk about in a separate slide, so just bear that in mind. So EVC, enhanced Vmotion compatibility, different versions running in processor, on-prem versus the cloud, how do we deal with that? Okay, so going on from live migration, actually let's check to see how our virtual machine here is doing. Okay, it's moving across. Oh, almost done. Almost sitting over in, let me refresh the screen, maybe it's done already. 99, what I'll do is I can check up on it. This is, I was talking earlier about that embedded link mode, or sorry, the hybrid link mode. So here is that single pane of glass where I'm looking at the top here at my vCenter server in the cloud, at the bottom here, my vCenter on-prem, and if I go into the cloud, this is my cloud software-defined data center, go into my cluster, and if I take a look at, actually I should probably look at my compute resource pool. Within that, I have my test resource pool, and within my test resource pool, I have Migrate 02, so that's the machine that I just moved across. So that's now successfully moved from on-prem into cloud in about, like I said, about 3 minutes. So a user might experience, just as with regular Vmotion, perhaps the loss of a single ping. So that's Hcx with live motion, very straightforward. So cold migration, the great thing about cold migration is it's probably the simplest approach. Once you put that VPN in place between your on-prem and your cloud, you have some caveats. You want to be vSphere 6.0 update 3, or later 6.5 update 6.5D, or later also 6.7, for example. You have your firewall rules that need to be put in place. You can use a standard switch. You can use a distributed switch. And then after that, it's just the same. I have a canned bit here, which I'll play for you, if this is going to play. Yeah, so I've gone into vCenter. Within that vCenter, I'm simply going to pick a virtual machine. I'm going to turn it off so that it's off to make it cold migration. And the great thing about it is that it looks just like your cold migration on-prem. And that's one of the bits of feedback we've had from the VMware Cloud and AWS solution. It is just like on-prem because it is just VMware. And again, that talks about the same skill set and the same tool set. So I'm just changing both my compute and my storage. I'm picking my destination on the cloud, in this case, my compute resource pool. I'm going to pick my workload data store, click Next, the folder that it's going to go in, and finally, my network, and I can choose whatever network I want because this is a cold migration. It doesn't have to be on the same network. Click OK, and that's it. Then I'm ready to go. Click Next, click Finish, and that's going to migrate across. So the point here being, it is just like your regular on-prem migration tool, because it is your regular on-prem migration tool. So, content library, I mentioned this earlier, another way of getting workloads from on-prem into the cloud. For those of you that use a content library, you're familiar with the process. It's simply a menu item. As you can see here, it's a menu item within your interface. You create a content library, you populate it with templates, or with ISOs, or with scripts, and you publish it. You're going to publish a URL, and then on the cloud side, you go and subscribe to that URL, and automatically things sync across. Seriously, it's a great way to very easily start taking some templates, the ones that you use on-prem, keep it consistent, move it into the cloud, and then start deploying virtual machines or workloads from the same templates that you would use on-prem. So that's the content library. So, various steps of moving that forward. I promised I would talk about enhanced Vmotion compatibility, or EVC. So you can appreciate that with different chipsets on-prem or in the cloud, and we use Broadwell in the cloud, by the way, on our instances within EC2, within Amazon space. So we don't use cluster-based EVC in the cloud. I mentioned we use the Broadwell chipset, and so if you're moving now, if you're live motioning a virtual machine from on-prem into the cloud, what happens if you have, which is likely the case, different chipsets? Well, moving it into the cloud, no problem, because it's going to be the latest and greatest. And so long as you don't power cycle that VM when it's in the cloud, you can move it back to on-prem. No issue. If you do power cycle it, it's not stuck forever in the cloud. It just means you have to cold migrate it back to on-prem. If you have a Broadwell chipset on-prem already, then there's no problem moving stuff back and forth. But again, enter Hcx. Remember, from Hcx, we can actually take an older VM and move it to the cloud. So what that does, and the way that works, is that Hcx actually introduces a per VM EVC mode, which permeates across power cycles. So if you move that to the cloud and you power cycle the VM, you can still Vmotion it through Hcx back to on-prem. Okay, 3 minutes left. So, a little bit of review. Hopefully we are, in fact, all clear. So I call this the 3 steps to happy, healthy migration. The first, we're going to deploy a software-defined data center, which is just a GUI walkthrough. Again, it takes about 2 hours, which when you compare that to the hours, the days, the weeks, or the months of what it takes to provision a physical box, a single physical box, 2 hours for a fully defined, software-defined data center is looking pretty appealing, and then only 10 minutes to deploy any new server after that. So we stand up our data center, then we connect that data center to our on-prem using one of the methods that we've gone through today. So we're going to use our layer 3 IPsec VPN. Perhaps we're doing a layer 2 stretch. We're going to use Hcx most commonly, and we also have the option of using Direct Connect. If you have a Direct Connect already in place, you don't need a new Direct Connect. You simply carve off a private VIF, a private virtual interface, for VMware Cloud and AWS. So you can use your existing Amazon AWS Direct Connect. And then the third part is we start migrating workloads. And again, we can do cold migrations, the warm migrations where we're seeding it and then turning it off and turning it on at a time of our choosing. We can do that same live or bulk migration live with seeding it, moving things across in the space of a week or 2 weeks. At the end of that, we finish it off with a live motion, effectively having motion hundreds or more virtual machines from on-prem to cloud in the space of whatever we've decided, a week, 2 weeks. And then finally, we have the option of the content library. So that is everything. Sorry, I condensed that slightly just to end on time, even though we started slightly late. But it does allow a couple of minutes for questions. I would really like it for at least one person to ask a question. Simon. So the question is, are there any plans to integrate the HCX tool with something like VR operations? So, interesting question, because HCX has recently taken on a life of its own. At Amazon reInvent, VMware had a booth, because we were a sponsor, of course. And the folks that were manning that booth were very, very pleased to report that HCX is now officially, marketing-wise, VMware Hcx, so it's an entity unto its own, and there is a roadmap with VMware Hcx, which I can't stop just calling HCX. The marketing guys will have to come and shoot me. As long as there's no marketing people here, we're good. So as an example, so not necessarily with VROps, although that could be on the future, but with Site Recovery Manager, for example. So HCX, you can imagine with the deduplication and compression, would make a great tool to augment site recovery, to move workloads, to fail workloads over to the cloud, and to fail them back. So yes, there are other plans with HCX. Anything else? Any questions on how we're moving or stitching the two things together? Yes? The VMware Cloud and AWS solution. So it is owned, operated, and sold by VMware, or sold by a VMware partner. So the bill that you would get comes from VMware. You pay VMware. There are potentially additional costs as you connect to your Amazon, your native Amazon space, and you're using Amazon tools, but in conjunction with the VMware Cloud piece, you could generate some, like for example, if you're using S3 bucket, but you're using it to back up a VMware workload. Well, that S3 bucket doesn't really have anything to do with VMware. Now, going across that link, it's free, but you might go outside of that, in which case you'll have some network egress charges. Those would come, in some cases, through VMware, in some cases, directly from Amazon. Yes? So the 4-node cluster, yep. So the question is, good question, thanks. So how do you capacity plan for your space that you require on VMware Cloud? There's a couple of answers to that. First, it's my experience and my suggestion that you do some kind of right-sizing on-prem first, because everyone knows that we're over-provisioned, right? People come to you and say, hey, I need to have 16 terabytes of RAM. It's like, yeah, no, you don't. Okay, I need 16 terabytes. No, you don't. So, but generally, it's not always in our control, so it does get bigger than we might like it to be. So the first step is to run some kind of sizing tool. If you have vSphere operations, vRealize operations on-prem, great, use that. If not, there are great free tools for that, RV tools as an example, Live Optics, so you get an idea of how much you actually need of cloud. And you should initially buy as much cloud as you need at that point. If you buy too little, so the bare minimum is a 3-node cluster for vSAN capabilities. If you buy a 3-node cluster, but really you needed 8 nodes, someone in management is going to say, what the heck are you doing buying 3 nodes? We have to increase already. You didn't tell me that as far as my budget was concerned. So buy as much as you need out of the gate. But remember that the cloud, by definition, is elastic. So that 3-node or 4-node cluster, you can specify thresholds that will cause it to increase when you go past those thresholds, and then decrease when you return to normal, which really helps from a capacity planning perspective. So you don't have to go and overbuy like you do on premise, the 15 other servers that sit idle waiting for Christmas time. When retail, as an example, picks up, it will expand and contract as required. So plan initially for what you need based on a right-sizing tool, and we have some right-sizing tools as well, part of the solution. A new one is coming out perhaps by the end of this week. We'll see how that goes. And then know that you can expand and contract by setting the parameters accordingly. Does that answer the question? Okay. Anyone else? Yes. 2, Simon, it'll cost you extra, man. So the question is, for those of you who are familiar, we have VMware Validated Designs, or VVDs, which are effectively templates or blueprints that you can use or that VMware Professional Services uses to build out your software-defined data center on-prem. So the question is, when will HCX link in with that? Is that accurate? Okay. So when will HCX link in with that VVD design? I don't know of any plans currently where that is actually scripted to happen from a roadmap perspective, although I wouldn't be, given the forward momentum of HCX, I wouldn't be surprised to see that within the not too distant future. But on that note, for the first time with the VMware Cloud on AWS solution, VMware has published a roadmap. And so if you Google VMware Cloud and AWS roadmap, you'll actually be taken to a landing page where you can see what's in progress and what's coming up, broken down into the categories of what's available now, what's in preview, so think of that as beta, limited availability, what's being developed actively, and what's being planned, broken down, filtered by, you have the option to filter it by a number of categories. This is going to be storage, networking, security, third-party tools. So if you wanted to know what is being currently developed on HCX, you could simply say, show me HCX, show me what's being planned, and if there is anything that's publicly available, it'll show up in that roadmap. And that's great, because it's the first time VMware has actually done something like this, exposing the roadmap publicly so customers can see what's coming on down the line. Same as pricing. Pricing is pretty transparent, same as it is with Amazon. You can go on to just Google VMware Cloud AWS pricing, and you'll have a pricing calculator that tells you how much you're going to pay by node, if you're going to do it on demand or in 1 or 12-month subscriptions. All of that pricing information is there as well. Sorry, that's a little markety. It sounded a little more markety or sales-like than I wanted it to come out as, because this is not a sales thing, but the question was asked. So, what else? Yes. So is it a physical server or is it an abstract, the VMware Cloud AWS? Each is a physical box. It's an i3 at the moment. We're expanding the number of to different types of images, but at the time, it's what's known for those that know the AWS speak. It's an i3.metal instance, which has 36 cores, 512 gigs of RAM, and 10 terabytes of raw NVMe flash storage. Anything else? Okay, we have questions that you don't feel like asking as part of an audience. You can come see me in a little bit. We're a couple minutes over time, but I appreciate the questions. Guys, thanks very much and enjoy the rest of the show.